Hello and welcome back to our Unity 2D tutorial series. Today, we're going to learn how to make a 2D controller for a platformer. Now, of course, this can be refitted to fit other games. However, I may make another video in the future on how to do a top-down perspective. We'll have to see. But without further ado, let's begin. The first thing we're going to want to do is make our scene. That way we can properly test our code bit by bit rather than all at the end. Now, this doesn't have to be anything fancy, as all we really want to do is test our player movement. First, I'm going to make a large ground base, adjusting till I see fit. Then, we're going to add a 2D box collider to it so it has physics. I'm going to add some pillars to jump over and a wall at the end, making sure to add a collider to all these objects as well. Then I'm going to do something a little special and create a one-way platform. To do this, you need to add two things. First thing is a collider, like before. Then you need to add a platform effector, which makes it a one-way platform. But to have it run, we need to click Use by Effector in our collider component. That's all for our scene for now. Now, let's make our player. Now, we are going to use a capsule as our stand-in. Make sure that has a capsule collider to go with it, and a rigid body. In rigid body, click Constraints, and make sure to lock your Z rotation so your object will not tilt. To test if you did it right, it should fall but not rotate, even if on the edge of a platform. Once you have that, we can begin coding. First thing we're going to do is define the member variables we need for our character to move left or right. The first thing I'm going to put is the max walking speed and an acceleration float, which can either be public or serialized. Next, we're going to get a reference to our input map. We're going to create an input action variable and a float to know which way we are going. Finally, we're going to add a reference for our rigid body. In the start function, set our rigid body variable equal to getComponent rigid body. This will find the rigid body component on our game object and have our variable reference it. Next, we're going to make a new function called onAwake. This is called before start while our scripts are still being loaded. What we're going to do is create a variable called map and set it equal to inputActions.findActionMapPlayer. What this will do is find the relevant action map from input actions and set it equal to our map variable. Also, var just means this variable is whatever type is put into it first and can only be used inside of our functions. Next, we're going to set our move action to the relevant action inside our map. After this, we're going to do two complicated lines of code. Move action dot perform plus equals ctx greater than and equal to input move equals ctx dot read value vector2 dot x and move action dot cancel plus equals ctx greater than and equal to move action equals 0. Now, I'm not going to get into the nitty-gritty of what this all does, but essentially, this will run this section of code whenever this input action is performed, and this one when it is not performed. Next, we're going to use two innate functions called onEnable and onDisable, and put move action dot enable and disable respectively. Basically, what this does is it reads this input when the object is active and ready, and stops reading inputs when the object is inactive. After all this, we can move to update and ignore it. Instead, we're going to add a new function called fixedUpdate. The difference is fixedUpdate is better suited towards physics, so use it if you want to move an object, and update for everything else. The first line to add is rigidbody.addForceX and set it equal to input moves times acceleration. What this does is apply a force to our game object equal to our acceleration variable, and input move will make it go either left or right depending on the key held. Next, we set rigidbody.linearVelocityX equal to mathf clamp velocity comma, negative walking speed, comma, walking speed. This prevents our speed from being greater than walking speed and less than negative walking speed. All right, let's see if this works. Now here are the values I'm using right now. And when we move, we can see that it takes us a bit to get to full speed. However, when we stop pressing buttons, the player sort of slides like a hockey puck. To fix this, we're going to make a physics material to add more friction. To make physics materials, just go to 2D, physics materials, and name it and set it however you like. Please note that changing the values while the game is running has no effect on the friction. You will have to replay the game to see what happens. Next, let's get our character to jump. To do this, we're going to need to add 3 new variables: a jump speed, a jump input action, and a bool called jump press. We will do a similar thing to what we did before, but this time we're only going to do the perform action and use it to set jump pressed to true. Don't forget to enable and disable your jump action. Now, in our update function, we'll add a new if statement that goes off if jump pressed is true. Inside it, set our vertical velocity to our jump speed, and outside it, jump pressed to false. The reason why we set jump press to false in our update function is so the user has to press the button every time instead of just holding it down. Now let's set our jump speed to whatever we think is good. When we play our game, we just need to press the space bar and our character jumps. However, there is a problem with this. If we press the space bar multiple times, we can fly. To solve this problem, we're going to need to use something called a raycast to detect the ground. We're going to need to add 4 new variables: a reference to our collider, a new type referencing a layer mask, and 2 floats named ground check radius and collider offset. First, use the get component function to grab your collider. Now we're going to create a new function, and this can be named whatever you want, but I'm going to name it onGround. Make sure your function returns a bool though. Now, in that function, we're going to set a float called yOffset equal to collider.bounds.size.y, which gets the height of the collider and times it by collider offset. Next, a new vector 2 with bounds.center.x for x and bounds.min.y plus y offset for y. This just makes the center of the vector a point a little bit above the bottom of the collider. Now the important line: return physics 2D dot overlap circle. In the parameters, put center to define the center of the circle, and bounds dot size dot x times ground check radius for the circle's radius. Finally, put in ground layer mask so it only detects the ground. And after, put not equals null. What this does is create an invisible circle that will return something if it touches the ground layer. And by putting not equals null, we are basically saying if it touches something, return true, otherwise return false. Now, because this is an invisible circle, it makes it hard to debug. Luckily, there is a way to see the circle. Create a new function called onDrawGizmosSelected. Make a new reference to your collider because this function does not run at start. Copy over some of our code for onGround and adjust the collider reference to match the new one. Now, put handles.color equals color.red. Finally, handles.drawWireDisk with parameters center, transform.forward, and then our radius logic. Now, before we leave, let's actually use our ground function. In the jump if statement, add an onGround, so it only jumps on the ground. All right, testing time. Here are the values for the variables. And when we have the player selected, there should be a circle showing us where it is checking for the ground. However, before we begin, go to your ground objects, go to layers, and make a new layer called ground. Set all your ground objects to that layer and set your player's layer mask to detect that layer. And now, we no longer fly. Using our new grounded function, we can make the player have less control over their side-to-side movement if they are in the air. Luckily, this is simple to add. Put in a new variable called air acceleration and go back to your horizontal force function in fixed update. Add an if statement so it only runs when grounded. Finally, add an else statement and put in the same line above, but this time use air acceleration. Testing this, we can reduce air control by setting a value that is lower than our normal acceleration into air acceleration. Now, while I'm not going to overcomplicate this script with extra quality of life features, I am going to add a variable jump height so you can be a little more like an Italian plumber. In essence, variable jump height allows us to jump higher if you hold the spacebar versus tapping it. We are going to need two variables, a serialized float called jump held speed and a private bool called jump held. In Awake, add two more lines for jump action, one for performed and one for cancel. Set jump held to true and false respectively. Now, go below our previous if statement for jump and add a new one. In this statement, put in jump held and add rigid body dot linear velocity greater than 0. In it, put rigid body dot add force y jump held speed. What this will do is continually apply a force when space is held. Eventually, gravity will overtake this force, at which point speed will be less than 0. The reason why we make it stop applying force after this is so that it drops down rather than floating down. Alright, let's test it. Here are the values I've set for our initial jump and our held jump. And the jump is variable. That concludes our video. Now you can play around with the parameters to make your platformer feel good. Now, I may in a later video add more features to our scripts, such as coyote time, jump buffering, and double jump. But that's all for now. Signing off.